In this video, I am presenting SentinelGraph, a anti-money laundering or AML investigation system built to detect suspicious money movement using graph intelligence. In real world, there is a problem where this project solves in that the money laundering is rarely obvious when you look at one transaction at a time. Suspicious behavior usually appears as a pattern across many accounts, such as one account seeding money to many other, or many accounts sending money into one money moving through several intermediates, or the money eventually returns to the starting account. So the Sentinel graph is designed to expose these patterns and make them easier to investigate. In this is exactly why the graph database is important here. Traditional relation database stores transactions as rows, but AML investigation is rarely about the relationships and paths. A graph database model account has nodes and transfers has edges. So instead of reconstructing network through complex choices, I can directly query the structure of the money flow. That makes a fan out, fan in, multi-hop layering, and circular laundering much more natural to detect. The tech stack for this project includes Python, FastAPI, Pandas, and the Neo4j compatible CognoDB on the backend, and React, Vite, Axios, Cytoscape, Tailwind CSS, and Lucid React on the frontend. So the backend handles the database logic and the graph queries, while the frontend handles the user interface and visual investigation experience. Now we'll go to the processor. First, we establish the connection to the CognoDB. That connection is handled the database, so the database credential stays private and browser never connects directly to the graph database. And there we have used two datasets, which is IBM AML datasets. The first is the main transaction dataset, and the second is the pattern dataset. The transaction file contains the full transaction records, including source and destination, banks, timestamps, accounts, currencies, payment format, and the laundering flags. Whereas the pattern file contains a labeled laundries groups, such as a cycle file, out of filing, and layering, and other suspicious graph structure. For these two files, I can extract the realistic information from the background activities and know the suspicious behavior. Then I perform the data exploration to understand the data structure, checking the columns and identify the useful fields. This step helps us to confirm that data was visible and how to layer patterns were organized. Then preparing the seeds. This is important because the full dataset is very large. So instead of comparing with doing with everything, I created a smaller graph that is prevent key suspicious structure. The seed data includes laundering transaction taken directly from the pattern file, and selected like sets of normal background transaction. This makes the graph manageable while still keeping the real fraud patterns intact. And there is a loaded of seed into the CognoDB, and testing these queries after logging the graph is connected to like around 13,000 nodes and establish the relation among 12,000. This gives a working investigation graph that actually supports the ALM analysis and query visualization. Now next is the backend, where the backend plays which we have used as FastAPI, where it's a middle layer between frontend and graph database. It exposes REST endpoints and health checks. Overall, like it detects takes out the overall statistics of fan out detection, fan in detection, account profile, multi-hop network, and circular cycle detection. Now that the main takeaway is from this front end is it returns the clean JSON response to the front end can use, and it can be make the app easier to maintain because all the Cypher queries stays in one place. And the front end which we have built with React.js, where it's fully dynamic and the data is updated very interactively, and it has four main screens like there is an overall dashboard, the ring explorer, and the account inspector, and the graph visualizer. Internally, the front end calls the FastAPI and pointer through Axios. Then the return data has card, table, matrix, and graph visualization. Cytoscape.js is especially useful because it returns the backend graphs result into the and so instead of such a raw interaction row, I can visually inspect like path, loop, and suspicious hubs. Now there is a let's say this is a complete walkthrough where dashboard shows the overall ALM statistics, including total account, total transfer, flagged transfers, and laundering ratio. The ring exposure shows the suspicious fan out, fan in, and hubs. The account inspection lets you to search an account and inspect it incoming and outgoing ledgers, bank inflations, and connection counts. And the graph viewer lets you to track multi-hop money flow and detects a circular laundering route. So for example, when I open a suspicious account, I can exactly how funds move through the network and whether the account is a part of large laundering structure. Now we came to the final conclusion where SentinelGraph turns AML detection into a graph investigation problem. It uses CognoDB to store and query connections, transactions, and FastAPI exposures, and ensures the backend services and React of Cypher to make the results very easy to inspect and